Wanted to welcome all of our panelists today for our ARPA-E summit discussion around building electrification. Building electrification is becoming a significant area of focus as we think about a decarbonization of end uses within the US economy and global economy. One of the things that the Biden administration has talked about is a 50% reduction in carbon by 2030. And in that, as we look at it going forward, building electrification or building stock in general, whether that be residential, commercial, retrofit or new construction, is going to be a key area of focus. I just wanted to ground the group with a few stats around the role of buildings in terms of carbon footprint and the opportunity that we have here. Then I'll go ahead and introduce our distinguished panelists that we have today to really begin to pull apart this opportunity that we have and talk to us about technologies that they see in terms of being able to help reduce the carbon footprint of the building end use sector going forward. I did want to mention first and foremost that when you think about buildings, we do think about what their contribution to the overall carbon footprint is. And we're looking at US specific numbers here, but when you look at that, you see buildings contributing about 10% of the US carbon footprint that ultimately, as the Biden administration has discussed, looking at a 2050 zero carbon strategy. So across all sectors of the economy, whether that be the electricity generation or the power system and all the end uses, ultimately 100% net zero carbon footprint. So when we think about buildings being 10% of that particular area of focus, we also know that they use about 1/3 of the energy, the final energy within the US is consumed by buildings, and about half of that is directly attributed to non-electric uses. So obviously a significant opportunity to transition this particular sector of our economy. A few of the areas that we have noticed as various groups have been modeling the impact of electrification of buildings going forward, what they are beginning to see is potentially a shift for the power system from a summer peaking period to a winter peaking period. And of course, we'll have to figure out how that then is managed by the utilities and others that are providing utility services or power to end use consumers going forward. So let me just close and then introduce our panelists by once again reinforcing it's not a question of if buildings need to be electrified. We know that they will have to be electrified on some level in order to support this transition to a lower carbon or zero carbon future that is being proposed. So we've asked our panelists today that I'm going to introduce in just a moment to help frame some of the challenges that they see that are associated with increasing energy efficiency of the building stock, decarbonization of the building stock, and energy flexibility. And of course, overlaid in all of those challenges is the thought that what do we need to do from a transformational technology perspective in order to accelerate and enable this transition? And the final comment I'll make is we can't overlook the importance of affordability. We all know that from a consumer perspective, an end use perspective, affordability of electricity, resiliency of electricity, and the ability to ensure safety and health and economic prosperity are key considerations as we think about this transition. So let me briefly introduce our panelists, and then we will get into each of the panelists making opening remarks, and then we'll turn it over to Q&A. I'm going to first introduce John Brashears, who is the founder and president of Architectural Applications, which is an engineering and architecture design consultancy firm dedicated to developing smarter and more elegant solutions in the use of our resources, not only in the natural environment, but also in the built environment. John is an architect as well as a mechanical engineer. I love that combination. He has been instrumental in delivering benchmark green and resilient buildings, including the first net zero energy laboratory building in North America, and a net zero energy office building in the coldest US climate zone. So John, welcome to you. Second, we have Dr. Chioke Harris. He is a senior research engineer in the Building Technologies and Science Center at the National Renewable Energy Lab there in Colorado. Dr. Harris's research is focused on the development and application of multiple building energy modeling tools, as well as the development of high-performance building components in systems, particularly those focused on the building envelope. So welcome, Chioke, and look forward to hearing your remarks in terms of how we address not only electrification, but energy efficiency going forward. Our third panelist is JP Flaherty, and JP is a senior director at Tishman Speyer, overseeing global sustainability, energy, telecom, and smart building efforts for the company. He manages the sustainability certifications, investor communications, worldwide performance tracking, procurement strategy, and technology innovation implementation for his company. Important to note that they are one of the largest commercial holders of properties within the global footprint. And then finally, Sylvia Curran. Sylvia is with Con Ed, so we have the opportunity to get the utility perspective also today. And Sylvia works within Con Ed's R&D group and is currently managing a portfolio of diverse projects in gas, steam, construction, and energy efficiency end use areas. Sylvia is focused on innovations in safety, operational excellence, and customer experience. So once again, a very diverse and very impressive panelists, group of panelists that we have today. So what I'd like to do is offer each of you several minutes to kind of provide some of your opening remarks about technology advances that you see necessary in order to realize this decarbonization of the building sector. And John Brashears, I'm going to go ahead and start with you and allow you to make your introductory remarks. John?
Thank you, Rob. It's an honor to be here with you today. I think I'm going to start by stepping back and making the sort of simple statement that's worth keeping in mind, that almost all of the operational use in buildings and the attendant emissions that go along with that are driven by the fact that buildings exist in a dynamic environment, right? And the variability, the range of variability of the different ambient conditions, right? The temperatures, the humidity levels, the illumination levels vary through a greater amplitude than we prefer to exist as human beings. And so almost all of the operational energy use in buildings clearly goes to mitigating or damping out those amplitude variations. That's a very simple nutshell problem there. The opportunity here as we go to all electric, as Rob indicated, is that we can create more variables and provide better control and better optimization opportunities to match the conditions that exist, that the building has to exist within, to the conditions that we want to create on the building interior. So we hear a lot of talk these days about microgrids, and those can exist in a lot of different forms. It's a fairly generic term, but really we're talking about systems for power supply, power generation, and power storage, or energy storage, if you will, in different combinations that allow different variables to be turned, different gauges and knobs to be turned in ways that can operate in conjunction with the grid, or alternatively can operate in an islanded fashion and give us better control over a wider range to match the need to the conditions. So when as we start to adopt these systems, we have opportunities to fine-tune the demand and the use, as I said. We have opportunities for buildings to shed loads to better match the grid capacity curves, which is very important. We all know about the famous duck curve and armadillo curve and any kind of menagerie of curves around the country. And we also can optimize the building operation to match grid emissions profiles, to match grid capacity, as I said, or to match energy cost and any number of other things. So these kind of microgrids are all about better control and better optimization of building energy use. And the last thing I'll say about that is that there's a very happy additionality that happens when you spend the extra money that it takes today to implement these kind of microgrid systems. They do take right now more money and more space in the building, but you get these advantages I just mentioned, as well as the fact that all of these systems that are intended to increase the sustainability, the green operation of buildings, are exactly the same ones that enhance the building's resiliency and its ability to manage a sudden disruption or a change in its power supply. We've seen a lot of examples of that recently, and we know how important that is, and it's becoming an issue of increasing concern and awareness within the building community. So I think I'll leave it at that for now and look forward to further discussion when question time comes around.
That's great, John. A great overview, and loved how you touched on the flexibility component, being able to match building inhabitants' behaviors with what the building can provide, and do that more efficiently. And then also this resiliency concept that you talked about at the end, incredibly important as we think about end-use electrification growing significantly. Greater obligation from a societal perspective to ensure resiliency going forward. So thank you, John, for that overview. And Dr. Harris, how about from your perspective? Once again, I mentioned your background around building envelopes, so look forward to your opening remarks.
Sure, thanks, Rob. So one of the challenges that Rob already mentioned in his introduction is this transition that we expect to see in many regions from a summer peak to a winter peak. That's coming from the electrification of heating loads. So as you move your heating equipment to depend primarily on electricity, moving away from fuel-fired equipment, those heating loads are sort of inextricably linked to building envelope performance. Your interaction of the conditioned environment inside the building is ultimately dependent upon the extent to which you're able to control the exchange of heat and mass transfer with those exterior ambient conditions that you don't have control over. To really improve that control is really key to managing the growth in winter peak that we might expect to see in the future. You certainly can tackle building heating equipment performance, and improving cold climate heat pump performance in particular, I think would be especially valuable for tackling the winter peak. But I think a equipment-only strategy is only going to get you so far. You really need to address the challenge of envelope performance. That's particularly important because a lot of the existing stock in the US is a relatively poor performing envelope, a lot of air leakage, poor performing windows, relatively limited insulation. And we tend in the US, our building stock turns over relatively slowly. We're not replacing existing buildings with new buildings where that opportunity for envelope performance, even to meet existing codes, would be an improvement over the performance of the existing stock. So given that context, technologies that can address envelope retrofits and do them more cost effectively, faster, cheaper, and easier, something that's a less invasive process, that's easier for a homeowner or a building owner to take on, would be really advantageous. In terms of air leakage, that's a particular challenge because air leakage, apart from there's some easy, obvious things that you can do to improve air leakage in buildings, but in a lot of cases, you're getting air leakage all throughout the envelope. And tackling all of that efficiently, quickly, and cheaply is really difficult to do. So technologies that can tackle air leakage quickly and easily with minimal disruption to the building occupants would be particularly valuable. Insulation, there are options that are cost effective for some buildings, but not all. So with insulation and with windows as well, there continue to be opportunities for improvements in technology that would improve performance and also reduce the effort involved in actually conducting those retrofits. As John already mentioned, if you improve the performance of the building, it really helps a lot with resilience. It helps with passive survivability when there are disruptions, and it helps with load flexibility. If you can imagine, if you had a pumped hydro system and you pumped all of the water into the upper reservoir to get all of that potential energy, but then your reservoir was leaking all of the water back out in an uncontrolled fashion, you wouldn't have a great storage resource in your pumped hydro system. Similarly, if you want to use the building as a flexible resource, but you're losing all of your stored capacity from your building because your envelope is very leaky and has very poor performance, it's going to be really challenging to use that building as a flexible resource. So there may be strategies that can target existing buildings. It also may be that the strategy is actually to develop technologies that allow us to build new buildings much more easily and cheaply. Maybe the answer is replacing buildings entirely. There's probably challenges there with respect to embodied energy and total life cycle energy and carbon, but it's something potentially worth exploring. I also want to note briefly that there's an opportunity here, I think, for thermal energy storage as well. Kind of going beyond the traditional large-scale ice storage that we've seen in commercial buildings, but technologies that allow for thermal storage, potentially for both heating and cooling seasons. So again, going beyond the kind of cooling season or cooling targeted approach with ice storage to a storage system that can really help with this winter peak driven by heating demand. A big challenge there is going to be addressing controllability. Technologies that allow for control of thermal storage so that we can control the rate of charge and discharge, the timing of charge and discharge, I think are really important. Using something like a traditional PCM, yes, you may get a thermal storage system integrated into your building, but you probably don't have great control over when that PCM or when that thermal mass is charging and discharging. So adding that control would be a really valuable change and would really take thermal energy storage to the next level in terms of being a competitive asset in the sort of broader storage strategy for delivering flexibility and targeting that winter peak.
Great overview, Dr. Harrison. I especially liked your visual around the pump storage. Great visual to think about spending all that energy to fill it up and then having it leak and lose energy. So it's a great visual. I look forward to hearing more when we get to Q&A about thermal storage and technology involvement opportunities that you see there. So thank you. Let's move on to JP Flaherty. And I mentioned JP works for a very large commercial firm that manages and owns a significant amount of commercial space globally. So JP, your thoughts in terms of how we are evolving around building electrification, energy efficiency, and decarbonization.
Sure. Well, I mean, I'm, just touch briefly on energy efficiency to say we're all about energy efficiency in the sense that we're well aware we operate our own buildings. So if we operate them efficiently and we use less energy, it increases the NOI of the property value goes up. All of our investors are very happy. So energy efficiency is the no-brainer step one without having to say that out loud more than once. But I think the electrification side is where, so we build a lot of new buildings. We're building roughly 12 to 15 buildings around the world today, when we build very large office buildings and large complexes. Average size of our developments is in the roughly 500,000 to 1 million square feet range, if not larger. So we're building big structures. And we operate in 8 states of the US, 4 countries in Europe, India, China, Brazil. And so we're building buildings of all varieties all over. We can build an all electric building today, no problem. And we are. And in fact, we are. It's not a secret that we're the development manager for JP Morgan Chase, who's building their new headquarters at 270 Park. And they are contemplating all of these options. And for folks like that, when you have very long hold periods and you're going to own the building forever, going all electric today, although they haven't made that choice yet, but we think they will, it makes all the sense in the world. It's challenging though, because when we look at the economics of telling an owner to go to one of our partners or one of our investors that we want to go all electric today, it doesn't make sense. It doesn't make sense financially, and it doesn't make sense from a carbon perspective. If you build an all electric building in downtown, or rather in Midtown Manhattan today, understanding that we've conveniently closed all the nuclear power plants, you're building a 100% natural gas fired electric driven building, which is not efficient, right? Meaning with all the line losses and other issues, building an all electric building in Midtown today is the guaranteed way to spend more day one, more day two, and use more carbon. Great, awesome, sounds like a great proposition. So how do we get over that and get people to do that, knowing that you need that building to be all electric in 15 years when the grid delivers that level of decarbonization such that the energy that you're using is enough, the carbon quotient of that energy has gone down enough to make sense to do that. And the reality is in most grids, even with very aggressive mandates by states, that day when it makes sense to be all electric is well into the 2030s, right? And there's no questioning that. I mean, New York City currently, literally having just closed the last reactor 3 weeks ago, we're at 99% natural gas fired. In Boston, our buildings are roughly in that same range because they've closed all the nuclear power plants. It's all natural gas. The magic date is different for each grid and each e-grid region around the country, but it's far into the future, except for a handful of scenarios in the United States today. So how do you drive people to want to, new building is one thing. Maybe you think, okay, well, I'm going to deliver in 5 years a new building. And so by that point, we'll be pretty far down the path. And maybe that makes sense, even though it doesn't still from day one, day two, or carbon, but maybe it makes sense because, you're doing the construction now and you don't want to go back and retrofit in 10 years. But for the vast majority of our existing buildings, retrofitting to all electric is not going to be economic for a very long time without a substantial change in the economics of carbon and electrification. And Sylvia, we'll talk about this in a moment, but Con Ed has done extensive studies on electrification of their own buildings, of the building stock in New York City in general. Con Ed has the advantage of selling all three forms of energy available in the city of New York: steam, electric, and gas. So for them, it's all the same, pick your poison. But if you want to go down that road, like right now, going all electric just doesn't make sense. So how do we bend that curve to make it worth doing today? And how do you convince people to do it when it also doesn't make sense from a carbon perspective today? The problem is, though, that if you wait until 2034, when the grid is magically ready to go in Boston, every building goes in 2035. That doesn't make sense, right? So it becomes a societal versus building problem as to how do you encourage building owners to do things that are not in their own personal building interest, but are in society's interest, in such that the transition doesn't all happen or is required to happen in like a 24-month time frame in each grid, right? So it's very interesting to think through how you might set incentives and others to do that, but today none of that exists, right? So today it's cities begging owners, please retrofit to all electric because, 15 to 20 years from now, it's the right idea. That's a tough sell.
Yeah, great overview. And I love that you touched on both the retrofit and the new build, JP. I appreciate that. Did want to make one quick comment in terms of, you mentioned the utilities and of course the carbon footprint of the utilities. And absolutely, I should have mentioned this at the outset, the Biden administration, as part of their proposed plan, is that the electricity sector would achieve an 80% decarbonization objective by 2030. Now, the electricity sector has made significant progress, and I'm sure we'll hear from Sylvia on this in just a moment, in terms of decarbonization of the power system. But as JP mentions, obviously, it is not there yet. The one thing I will say is we continue to see progress, and I call it the gift that keeps on giving. As the electricity sector gets cleaner, if you have installed these technologies, you benefit from them as the electricity grid and the power system gets cleaner. So the other point that you really pointed out, which I think is so important from a technology perspective, shelf life. How long do we allow systems to remain in place before they need to be retrofitted or updated? And how do we ultimately think about that? And the economics are going to be very important. So great overview. Thank you, JP. Look forward to more discussion in the Q&A. So Sylvia, you bring to the table the kind of the utility perspective, and JP just mentioned how important that is in terms of not only supporting reduced carbon. If we're going to electrify end use, then it better be with reduced carbon footprint from the utility. So Sylvia, what do you think as some of the technology challenges that you're faced with from a Con Ed utility perspective? Sylvia?
Yeah, thank you, Rob. Yeah, it's interesting to hear the perspective of the colleagues and then top it off with utility. I have to agree with Jonathan. It's a tough role Con Edison is in because we do manage all three commodities. We have electric, gas, and steam. And you want to design the solution that fits the target most effectively with all three commodities, and yet the target and the political and regulatory situations are all in such a dense and heavy situation that you really have to make sure you not tip the scale in each side. You have to think of customer experience, you have to think of cost, you have to think of regulatory requirement and political requirement, and then in New York specifically, building aesthetics play a role as well. But never to say 85% reduction of greenhouse gases by 2050. That's 30 years from now, technically. That's a huge reduction. And talking about 100% carbon-free electricity by 2040, that's 20 years from now. Again, that is an aggressive goal. I must say that we are definitely working as a utility to comply with these rules, but there is a way how to do that. If you would take all the buildings today and let's say magically switch them to electricity, you will create inadvertent problem that you will have to deal with, such as summer to winter peaking utility. And it won't be the same peak. It will be by magnitude larger peak, and infrastructure may not be ready for it yet. So something like that from planning perspective is done many years in advance. From utility perspective, our infrastructure, our electric infrastructure is built to certain peaks. And if that peak is different, you are trying to manage it with different tools as a utility to avoid building further substation, further infrastructure. And the tools in the packet we have are different. We have energy efficiency, we have demand response, we have non-wire solution, and we are encouraging these type of solution to be deployed to maximum level possible, so we don't have to go to capital investments. There's too many moving parts. You have EV vehicles coming on the road. They're going to create certain load profile, additional load profile. You have all these buildings, they're making decisions, and usually most of these decisions are made at the point of failure. About 95% of HVAC is being replaced as it failed. And usually those are not very rational decisions. You kind of, if in the middle of the summer, if you don't have a HVAC system, you kind of not thinking heat pump, you think give me a replacement, same of kind. And you must think this more strategically, because the life, like someone mentioned, I think Chiaki mentioned, the life matters of the equipment, right? If we investing 20, 25 years forward, we want to think more what would be the compliance required by then. And then, so I do want to mention, I represent R&D, so we definitely look at technologies and what momentum industry is at and where we should be in the future. So we look at different HVAC deployment, we look at building envelope and materials, and you have to appreciate, for us as a country, for us as a state, to meet these targets, and for us as a utility, we cannot make this target alone. Just the energy sector contributes maybe up to 30%, even less. I don't know exactly percentage, but there is additional 30% of the building itself opportunities, and that is out of utility control. We can 100% control our own emissions and our own assets, but if it comes to the building, these are our customers, and we can help them, guide them, incentivize them to move towards clean energy. But at the end of the day, it's their choice. It's also the cost that drive their choice, and it's aesthetic, and it's the timing, and they have choice. So I think from the research and technology perspective, we try to look at from the building perspective, we look at the solution that can temporarily create energy efficiencies. We do also evaluate gas heat pumps as a temporary way to move towards electrification. So our point of view is to be open to any solution that can accomplish the goal, and be very mindful to not tip the scale in the wrong way, so we're not ready with the infrastructure.
That's great. Yeah, great points in terms of consumer preference, Sylvia, that at the end of the day, that I know is a big driver for all of our panelists, to make sure that the consumer preferences, economics plays a key role in that preference also, to make sure that it's feasible. And I lived the experience you talked about in terms of shelf life. My water heater recently went out, and I was stuck with what's available, either that or a very unhappy family. So I think one of the questions as we think about technologies is what is available, and how do we ensure that these emerging technologies are available when needed. So let me open it up to Q&A. I appreciate all of the panelists' perspective, but now I'm just going to bounce around with some of the Q&A based upon comments that each of you made. And I'm struck, JP said it, all of you have mentioned energy efficiency as being kind of a core fundamental principle around buildings going forward. And yet we all know that, hey, there's greater opportunities to increase energy efficiency. And we've seen some of that recently over the past 5 years. LED lighting, a significant improvement in terms of a more energy efficient technology. At the end of the day, building electrification of end use is a more efficient approach than its equivalent fossil counterpart. So I want to open this up, and John Brashers and Chiaki, I think I want to direct this one to maybe you, and think about the energy efficiency aspects. Each of you mentioned it, but what from your perspective, and once again now focused on emerging technologies, where are the next greatest opportunities? that we're looking for technology development to really improve upon a building's energy efficiency. John, let me throw it over to you. And from your perspective, as you think about buildings and design of them, what are your thoughts around where we have the greatest opportunity for energy efficiency improvements?
Yeah, thank you. It's a great question. The efficiency of all kinds of technologies are improving, on some faster than others, unfortunately. I do think that, and Chioke may also weigh in on this, that one of the great opportunities in buildings lies in the envelope. We have 3 decades of very large commercial buildings that have 3 decades worth of deferred maintenance on their envelopes, what my facade colleagues refer to as the leaky generations of buildings, right? And the maintenance has been deferred because the cost of doing something about them is immense. But although few in number, they're happening with increasing frequency. If you think of the Willis Tower in Chicago or the Empire State Building in New York, just to give 2 examples, some major interventions in the facade have been done to dramatically improve the buildings and repair that leaky generation, right? From leaking heat, from leaking air, from leaking moisture, and any number of other things, not to mention the emissions that go with that and the damage, potential damage. So to me, the problems of building better envelopes that are more airtight, more heat tight, more moisture tight, and also durable when you are joining a number of discrete elements into a continuous barrier in the field is one of the big challenges.
And John, let me just ask you a follow-on before I turn it over to Chioke to address the same question. What are the economics barriers that you see? What's driving? It seems to me if I am building a new building, I realize you mentioned the amount of stock we have that's decades old, but if I'm building a new building, are there gaps in energy efficiency that you see that aren't economic today, where the cost needs to come down in order for them to be deployed, or by and large is new construction fairly efficient?
No, there are certainly gaps. I'll tell you a story because I'm very interested in facades as well, like Chioke, and have done some work there. A number of years ago, earlier in my career, got very excited on trying to develop a better way to do curtain wall, window wall, which are the kinds of enclosure systems that are mostly glass with metal or stone panels that we see on most of our commercial high-rise buildings. And when you look at American products sold in this country to do that job versus things you can get elsewhere, for example, in many European countries, the performance difference, the thermal insulation levels are no comparison. The European products are so much better. And so we went to sort of understand what the differences were and how we might be able to either develop those kind of products to be sold in this country or get better representation for selling those products that are made elsewhere in this country. And I spoke to some of the European curtain wall manufacturers saying, how do we make a better thermal product? And they said, we know how to answer that question. The answer is not a mystery. The question is not how do we do it? The question is how do we get the US market to pay for it?
Great feedback. The economic challenge that comes into play again. So appreciate that, John. So Chioke, you mentioned energy efficiency also. I mentioned all of you have indicated energy efficiency being important. You also talked about thermal energy storage in the building envelope. I'm just curious your perspective, once again, from a technology perspective, where you see the greatest opportunity for continued advances, energy efficiency, building envelope, and systems.
Sure. So Rob, I want to start by going back to something that you mentioned, the example of LED lighting. I think that is often held up as an example of this like huge efficiency success story. And the underlying reason, a big part of it is lighting has a very low or near zero switching cost in a lot of cases. LED lighting offers improved attributes. You can potentially control that lighting. The quality of the lighting may be better than what it's replacing. And the incremental, in a lot of cases, particularly for residential customers, you can do it one lamp at a time and you can do it yourself. As bulbs burn out, you go to the store, it's readily available. You can go down to whatever store is closest to you and pick up a bulb and screw it in or drop it into that fixture. And there you go. You've gotten a huge efficiency gain and it's at a very minimal cost to you. When you think about the building envelope, we're just not there yet in terms of technologies. We have technologies that can improve the performance, but not in the same way that you can improve the performance of lighting with an LED, where you just drop that bulb in, boom, you've got an efficiency gain. It's a big project. You need lots of people, lots of trades involved. It's very invasive. You have to really do a lot of demolition to access the components in the envelope that you want to upgrade. So it's messy, it's slow, it's labor intensive, it's complicated. And in a lot of cases, it's even difficult to find someone who's willing to do it. I have a colleague who used to work for an installation manufacturer. He wanted to add continuous installation to a rental property that he had, and he could not find a contractor that was willing to do it. He eventually got a couple of bids that were these sort of like, if you really twist my arm, I'll charge you an enormous amount of money for the inconvenience of being forced into doing something I don't want to do. So getting to a place where these retrofits are much easier to do, much faster, potentially DIY or partially DIY, less invasive, would really move the needle, I think, in a big way, where we would get to a place where it's more like the efficiency gains we get from appliance standard improvements or from LEDs. With thermal storage particularly, I think the challenges there's a lot of technology opportunities there in terms of reducing costs, like a lot of these technologies, but also improving performance, improving durability, and proving out that durability. I think there's a lot of customers who might be interested in implementing thermal storage, but are nervous about the prospect of taking a technology that's still fairly early stage, given that the building envelope tends to be one of the longer lived components. I mean, it's not like a light bulb or an HVAC system where you sort of expect it's going to be replaced after 15 years or 10 years or however long its lifetime is. You might expect the envelope to last 50 years, 75 years, 100 years. If you're putting a technology that was developed, it left the bench top 2 years ago, you're going to now put that all over inside your building envelope. And mind you, that building envelope that was very difficult to take apart to get that storage in there. And then you're going to say, it's going to last 100 years. I think a lot of people want to see a lot more proof in that pudding before they make that kind of capital investment. So technologies either that are much easier to remove and replace, very low cost. So when they do fail, you can just rip it out and put new materials in very quickly and easily, or kind of proving out that longevity and demonstrating that it can kind of last as long as the other building components is really important.
Yeah, and the themes that Chioke and both you and John touched on also earlier and that have come out, that thermal energy storage, of course, contributes to this notion of flexibility in terms of how do we match building inhabitant needs with what we can do from a power system perspective. So I'm going to bounce over to Sylvia here and just ask her that particular question. Flexibility is becoming an important area of focus. We know that end-use electrification will increase the opportunity for flexibility, whether or not it includes thermal energy storage or not, just in terms of end use. And from a utility perspective, what do you see the technology challenges in terms of taking advantage of this increased flexibility?
Mm-hmm. I want to touch one comment that Chioke was just explaining and put it on perspective, and then I'll hop on your question. I want you to appreciate the density of the city and how the building envelope truly plays the real role, because I can't agree more enough. So nationally, the building represents 41% of energy consumption, but in New York City, the energy used in building is 73% citywide greenhouse gas emissions. So the opportunity in the building sectors are enormous. And I think specifically, if you start breaking it down, and if you think about the evolution of the building from now to 2050, all the plug loads, ventilation and lighting, everything that could be electrified will be electrified very quickly and start shrinking the entire building load profile. And now the envelope will become a pollution drag of the building, and it will be more emphasized how important it is to actually work on that. So I think to that point, there will be plenty of more research and evolution in building envelopes, infiltration, and I couldn't agree more about the materials unavailability, market not being ready for it, and the cost being completely deterrent to implementation on really high resistant, thermal resistant envelopes. So to that point, And your second part, and your main question was about the flexibility, right? Resiliency and what we could do about that. Okay, so I think from a thermal perspective, you have to think from the customer's decisions if you lose the power, right? The electrification couldn't be more exemplified during the Texas, right? During the Texas last summer, last couple of months in the winter, you could see how much you rely on the gas or some sort of alternative form of energy. I'm not even saying gas, but you think of how do I make building resilience? The hospitals, essential business, that's definitely important. If you can implement solution that like ice storage, that you can harvest the energy on the off-peak hours, discharge it during the peak hours. Think of creative way of making battery storage that is incorporated into building, that is not cost effective, that is not issue with the fire department, that is not issue with the space. You can start shifting the energy from one way to another. That's really what the demand response is about. And we are definitely looking at the solutions in that objective. Specifically, we were looking at wastewater recovery. If you think about the heat pumps, great idea. Average electric heat pump perform 3.5 COP, very, very efficient in compared to traditional heating cooling. However, if you go to the cold climates, their performance start degrade, their rate of performance start degrade, and eventually at certain temperature, they are easily comparable with the resistant heating. Gas heat pump, on the other hand, could really keep up with that end, and it could be a great blend for something like that, where you working on the cold climate and you required some effective heating, and still the average gas heat pump are not as common in the market as the gas, but they are at least double of efficiency of the traditional boiler. And we really have to think in terms of resiliency from the fuel perspective. So you have the front before combustion. You can green your grid from before combustion on the fuel side, and then you can green it on the post-combustion, like a carbon captures. And all of that has to work together. There is a local law 97 required building with a certain carbon limits, a large building, about 25 square feet. And the resiliency is really in coming up with a solution that can help you with the clean fuels, which is really utility role, and then allowing you a solution that can help you with the decarbonization on the post combustion. And if you do own the CHP or microgrid, I hope I answered the question, actually.
Yeah, well, you mentioned a really important part of it, Sylvia, the hybrid solution, which I think as we think about technologies once again, and for our participants to think about areas of focus for technology development, advancing hybrid solutions that may include a combination of the electric heat pump when supported with natural gas.
Dual heat pump, yes.
Yeah, I think as we think about flexibility, and I'm going to throw this over to JP now to think about it from a commercial perspective, because JP, you talked about economics a lot, and at the end of the day, all of this is important, but economics are maybe the key driver. And flexibility offers some economic advantages also in terms of being able to manage utility rate structures and use energy only when you need it. So maybe just your perspective, JP, in terms of anything that you're doing or gaps that you see in terms of enabling flexibility from a commercial building perspective.
Sure. So just quickly, 2 comments on what was previously said. One is, I hear everybody on facades, but like, dude, like that's not, people's view of how this is going to go down with facades is wildly divorced from any economic reality connected to any building owner in the United States of America today. Like there's no way that what everybody is saying is going to happen without massive economic forces going in that direction. And what I mean by that is, so people say, oh, local law 97 in New York, building performance standard, that'll drive you to do a facade replacement. No, it won't. Because the reality is, if you look, so there's a building right down the street over there, 1271 Avenue of the Americas. They just did a complete facade replacement, top to bottom. It's a 50-story, 1.5 million square foot 1968 office tower, modernist building, great looking building. They just completely replaced all the glass in the entire building, as well as all the mechanicals, the whole thing. And that building faced fines based on the carbon limits in 2030. And they spent, we don't know exactly how much, but we're going to wager about $140 million doing that retrofit. Now, they did it because they had an empty building and they needed to attract new tenants. They didn't do it on an energy basis, right? But that cost there, many, many, many millions, tens, hundreds of millions of dollars to do that, bought them 4 years of compliance under Local Law 97. They went from facing fines in 2030 to facing fines in 2034. The fines are nowhere close to $130 million over 4 years. So unless you've got some other reason to do that, you're not going to do it. And I mean, that's an example that was just done literally last year. The best glass it's not triple paned like crazy European glass, but it's very good glass, a very good facade replacement. And if that buys you 4 years under a carbon standard, then who cares? You're not going to do that. The money isn't even close to there. So I think that this whole facade conversation is only relevant with massive targeted dollars on the facade. My point being that we'll pay the fine all day than replace the facade, given where the economics are. So the facade side of the equation, I mean, New York State in their CLCPA law estimated that 73% of every facade in the state of New York would be replaced by 2035. I would guess today, based on today's economics, that number is 0.073%, not 73%. The decimal place needs to move by about 5 digits in the other direction. So the flag that is not likely to occur under today's economic or frankly, incentive structures. The second thing and just to add to that, we did a calculation at 200 Park Avenue, the MetLife building, which we looked at a facade replacement. And the payback to do a facade replacement on an energy basis was 185 years because you have to empty the building. There's no way to replace a facade without emptying the building. So I got to go, a 2.7 million square foot building has to go to zero rent, as in I have to vacate the building in order to do this. Hence their 175-year payback. So like, why, no matter what the fines are, you're not going to do that. So I think there's a lot to be said that the facade space needs all of what everybody just shared, but the economic forces preventing that are very strong. And just very, very briefly, 73% carbon for buildings in New York is true, but that is because of our friends at the Metropolitan Transportation Authority. We don't drive in New York. So the transportation sector has a tiny, tiny little piece. California buildings are no more efficient than New York, but the California number is like 43% because everybody's driving. It's all about what's driving that carbon number is not that buildings in New York are bad. I have to just say that as a building New York owner of New York office buildings, we're just as good as every other state, if not better. It's just our transportation sector is way farther along than other spots. And then lastly, I'd say in flexibility, I mean, we're all about flexibility kind of, but I guess what we've learned the hard way that you're asking building owners to make very long-term capital investments with a very unknown how this is going to play out. And I'll give you a simple example. A couple of years ago, Southern California Edison was giving away batteries in Southern California as was LA Municipal Power to deal with their various power challenges. And part of the deal is you got the batteries for free. So building owners were like, great, free batteries, we'll take them. However, what a lot of people didn't think through is that they came with the requirement of mandatory discharge, which means the utility decides when the battery is discharged. Historically, the utility peak and the building peak were the same. So why would we think that would be a bad gig, right? It's 3 p.m., 4 p.m., it'll work great for the building. Nobody anticipated a 9:30 p.m. peak. In a 9:30 p.m. peak, mandatory discharge batteries in your office building, now you're just storing flammable boxes for the utility and you get almost no benefit as the building owner. So, in that scenario, right, seemed like a great idea. Let's take a bunch of rentable space that we could have done, put a bunch of batteries in it. Again, seems like a total win, except that now we don't get any benefit from the batteries at all because of the way that the grid peak has changed. So I guess from a flexibility standpoint, sure, but these are long-lived capital items, 20, 25 years, and there's very, very uncertain outcomes in the back 15 years of that. It's very hard to convince people to spend that kind of money when you have absolutely no idea what the regulatory structure will be on the back end.
Yeah, and JP, of course, the economics continues to play a role. Let me and I'm going to throw this back to John just because I want to ask a little bit further about the retrofit in the building envelope. Sustainability drivers are becoming very important to a variety of companies, and they're thinking about their sustainability footprint, whether it be Amazon and electrification of their vehicles, or Google looking at their data centers and buildings, et cetera. But we expect that to continue to drive some behaviors going forward that may not always be economically driven, so that folks could talk about their sustainability footprint, their carbon strategies, et cetera. But you brought up a really good point in terms of retrofits. And John, when you were talking about the building envelope and retrofits of the building envelope and what Europe is doing, et cetera, let me just ask you from an economic perspective, are there areas of focus right away that you would suggest to a participant in this particular panel? Here's where we need help to drive down the cost of this particular technology so that it is more applicable to the US. You mentioned the difference between US and Europe. John?
Are there any, is there any one area of technological focus? There is a particular problem, and there's any number of technological improvements we could make, and I'm aware of several efforts that are happening, and that is airtightness of facades. And that might be new products, new facade products that have better airtightness. It also might be retrofit or remediation technologies that allow you to go to work on the leaky generation buildings without having to actually demount and replace the whole thing, which, as JP points out, is pretty much infeasible in most cases. So whether these are increased sealants or other kinds of remediation, better leak detection for existing or for newly installed facades, so you can understand where the problems are before you get the entire building buttoned up and it's too late. Those kinds of things, I think, offer enormous potential, because airtightness and being able to control what's going in and what's coming out of your building offer better opportunities. And I refer back to Chucky's amazing example about the leaky pumped hydro problem.
Yeah, great. And let me do this. We are getting close to the end, and I want to have the opportunity for each of you to answer one question. I'm just going to summarize a little bit of what I heard as we think about this next question. And the question I'm going to ask you, I'm going to say it now, and then I'm going to summarize, but I want each of the panelists to weigh in, and each of you will have just about a minute or so to do so. But what do you consider the number one challenge to be from a building perspective, a utility perspective, and a customer? So take all the stakeholders together and think about their perspective that must be solved to successfully electrify buildings. So I want to have each of you think about that. But what I'm hearing are some reoccurring themes. We talked about energy efficiency being foundational to everything we do. And the industry has been very focused on energy efficiency since the early 80s, and utilities specifically have really worked to enable driving energy efficiency solutions through some of the rebate programs. So energy efficiency is critical to this, and to the extent that it helps drive emerging technologies, it's going to be paramount to our success going forward. We can't think about decarbonization of the building sector, including electrification of buildings, if we don't think about the economics. And at the end of the day, economics are going to be key in order to support this. Heard this from many of the folks. The other thing I think that is very important to hear, resiliency. As we drive more folks to using electricity as their fuel of choice, and maybe eliminate other options, we need to make sure that we are thinking about resiliency, and whether that resiliency is built into the building itself or the utility is expected to provide it. Resiliency is going to be important. And the third aspect I want to put on the table is this notion of timing. If the average furnace in a residential home lasts 14 to 15 years, if I miss the window of opportunity to have that individual change out to a more efficient electric heat pump, as an example, then I'm going to have to wait another 15 years before I have the choice to do that again, from a consumer's preference perspective. So, but let me do this. I've given you the question. So once again, the number one challenge, thinking of all the stakeholders, the building, the utility, and the customer. What do you consider that to be in order to successfully electrify buildings going forward? And let me start with you, Chioke. What do you think that number one challenge is?
It's really hard to pick one because you just outlined several, and all of them are kind of very enticing.
I know it's not fair.
I think I'll say the challenge, I think that JP had highlighted really beautifully with the example of the MetLife building, where even if you had a technology. I think we've seen R&D programs at the federal level focus on improving the performance of the technology, improving the U factor of the windows, improving the performance of dynamic glazing, improving all of these factors of the performance of the technology itself. And that's really important and really valuable. However, it doesn't address the fundamental problem of, if you have a building and putting that technology into that building requires something like vacating the entire building to do the retrofit, it doesn't really matter how good your technology is or how low the cost of the technology itself is, that actual glazing product or that insulation product, if the process for installing that product is so costly or so invasive and so disruptive, so complicated to stage, that it makes it an absolute non-starter. You really have to address the entire kind of workflow for those technologies, from the performance of the technology itself and the cost of technology itself, all the way through to what it takes to actually get that technology into buildings, if you want to realize those retrofits in a way that's actually feasible for building owners.
That's a great point. And you mentioned that earlier using your example of the LED light bulb. We'll call it the plug and play solution, where it's simplified and can ultimately support the economics also. So great point, Chioke. Thank you. Let me jump over to you, Sylvia. Just curious your perspective.
Yeah, it's a really hard question. I've wrote down some notes here, and I'm like, which one is number one? So let me just give you my thoughts, and then I'll try to figure out which one is the number one. One is the circular economy. If you're thinking of building and changes in retrofits or new construction, think of circular economy. If you're deploying one solution that is depending on input of the fuel you have no control of, you may want to think of way how to make that fuel so you've controlled the entire pathway of that energy. And that goes inside, but really mostly maybe on the industrial side. You put energy in situ where you, depending on the input or byproduct, could be utilized, such as CO2 or inputs such as green energy. The second one, which is pretty important, alignment between the political, regulatory, and the cost. This has been told through this panel all throughout. If you don't have affordability and availability of the product, it's no good to you. And the utility incentives should be aligned with that. And the drivers as a carbon targets should be aligned with that as well. But I think at the end of the day, maybe what's the most important is the energy study. Because if you look at the energy flows in and out, energy cannot be destroyed. We all know thermodynamics. So if you have a good study, non-biased study, that can perform the energy assessment and help you to prioritize, such as where do you have the biggest losses, how can you really address the shell of the envelope, and when you focus next, and give you really like a pecking order what to do. And also that study can you offer the material that are more advanced and more available, maybe costly, but you understand the trade-off in terms of the R or U value as opposed to cost. Then you have a little bit of a more of a comprehensive picture and making more educational decision on your investments. So I think energy study will be the number one for me, because you're coming a little bit informed into the decision where you want to invest.
That's great. And I love the concept of the circular economy, understanding the end-to-end impact at the end of the day. So as we are providing this feedback, simplification in terms of installation, the end-to-end, the circular economy, this will allow the participants to think about what they need to use as criteria as they are thinking about potential solutions going forward. So thank you, Sylvia. Let me turn over to you, JP. What do you think of the biggest challenge that you see out there to successfully electrify buildings?
I mean, I guess I would say the lamest possible answer, because it's like, I hate this answer, but it's regulatory uncertainty. Like, we just don't know where everybody wants building owners to make massively gigantic investments with huge time frame issues with no regulatory certainty at all. And that's very, very difficult for most big owners to do, right? I mean, the perfect example of this is New York City spent the last 10 years convincing every building that was on fuel oil 4 and 6 to switch to a natural gas boiler. Okay, we're wrapped up with that. Great. Now we're going to start a new program where we're going to tell all you people you made a huge mistake and you have to rip it out and put in air source heat pumps. And you're like, wait, what? You just gave me money to replace this boiler that's 30 years, and now what do I got to do? And I face fine. And by the way, I just got this boiler that you recommended and told me to put in, and now I face hundreds of thousands of dollars of fines annually for using energy starting in 2050. Why? Like literally, what are you talking about? So I think the building, and it's a lame answer because, you know, things change, government policy changes. I get all that, but the problem is you're asking the private sector to make incredibly long-term capital investments with no certainty at all that any of that will be the case tomorrow, right? And it's funny because I put a slide together the other day in one of our decks for the talking about our decarbonization plan at Inspire, and one of the things was regulatory uncertainty, parentheses, US only, close parentheses. We're not worried about this problem in the EU. We're not worried about this problem in, you know, plenty of other countries. There's no regulatory uncertainty in China. There's no regulatory uncertainty in Europe. It's a US problem that we cannot decide what it is that we want to do, and every 5 minutes change it, and each state's doing something different, each city's doing something different. We do something in one city, they're like, thank you very much, and then this other city is like, if you ever do that in our city, we're going to find the snot out of you, right? And it's like, what? So I would just say with many different jurisdictions, many different states, and the federal government constantly changing their views as to where they'd like to go, it's and in return, then in those changes demanding massive, expensive capital retrofits with no certainty, very hard for owners to really want to get excited about that. So
yeah, and you raise a great point. And I know it's for the utility as well as for the end use customers, as well as thinking about the building owners, and that is the risk of technology investment and stranded assets. And so certainty around where that endpoint is going to go. The other point that you brought up before I turn it over to John to close this out really gets into, if we don't have certainty as to where our focus is, we are allowing other countries to perhaps take the lead in terms of becoming the technology leaders in these areas. So I know that the Biden administration is focused on the US and US manufacturing and US technology development. So I think you raised some very good points in terms of a little bit more certainty in the regulatory arena would help in terms of driving adoption in electrification. Thanks, JP. So John, why don't you bring us home? What do you think about the number one issue from your perspective?
Yeah, I'll make it short, sweet, and a little bit naive to boot. Human behavior is the biggest challenge. I mean, we could move buildings in a much better direction even today, even without new technologies. And do we move it that way with financial carrots or regulatory sticks? Wouldn't it be nice if we moved that way just because people wanted to do the right thing? Early in my career, worked for a crusty old architect who was talking about getting buildings built the right way in the field. And he would say, the contractor can do anything. He just has to want to. So wouldn't it be nice if we just had people who wanted to build the right kind of building?
Yeah, a great point. Let me just summarize and then close for the group. First of all, I want to thank each of you. Great insights, John, JP, Sylvia, and Chioke. Really appreciate you taking time. The areas that I heard at the end, and I just like to summarize this because the participants ultimately need some guidance as they think about this challenge going forward. But Chioke mentioned simplification. At the end of the day, it's got to be simple to install, so that it doesn't create an economic burden in terms of that aspect of it. Second, Sylvia mentioned the circular economy in terms of thinking about the end-to-end use of whatever materials or application you are, so that as you are thinking about technologies, think about that. And I think that can be especially prevalent as we think about some of the emerging renewable and battery storage technologies. What are we going to do with those at the end of their life cycle? And then JP, you mentioned, of course, the stranded assets, technology obsolescence, the importance of the industry regulatory environment to support that. And I think that that's incredibly important. You know, my advice to participants who are thinking about emerging technologies is really to think about recognizing the economic impact of stranded assets, and to the extent that they can play a role in some solution is going to be very important. And I'll throw hydrogen as potentially one of that to utilize existing infrastructure. And then John, you closed us out in terms of the consumer behaviors. And it's not only the consumer behaviors, maybe that's what will be necessary to drive contractors, builders, et cetera, but consumers demanding that they have sustainable, decarbonized buildings going forward. But once again, great insights from the entire panel. I really appreciate everyone's time today and hope that you have a wonderful rest of the week, and look forward to seeing each of you again soon, shortly. Thank you.